expand and condense logarithmic expressions. Our objective here, we want to expand and condense logarithmic expressions, just like the title says. So what do we know? Okay, well, we know what a logarithmic function is. Any function of the form y equals log base b of x, where the base b is positive but not equal to 0, and the argument x is positive. Excuse me. And we know, we learned these three properties or these three rules of logarithms in a previous video: the product rule, the quotient rule, and the power rule. The product rule, the log of a product is equal to the sum of the logs of the factors. The log of a quotient is equal to the difference of the log of the numerator and the log of the denominator. And the power rule says we can move the power of the argument and multiply it, move it to front and multiply it by the log. Okay? So our goal here is we want to expand and condense. So what does expand mean when we talk about expanding logarithmic expressions? It means we want to write a single logarithm. We have one log and we want to expand it. And we want to write it as a sum, difference, and or multiple of logarithms. We want to make it as expanded as possible. Okay, as many different parts as we can. And we want to use these properties right here to do that. So let's take a look at a couple of examples. Use the logarithmic properties or rules to expand this one. This is a single log expression, log base b of the product of x squared times the square root of y. Expand that as much as possible. Okay, so let's write that down. This is the log base b of the product x squared times the square root of y. Okay, well, I've mentioned the word product, so let's apply the product property and say this is the log base b of x squared plus the log base b of the square root of y. Okay? So that's applying our product property. Now we can look at the first one of these and we can say, wait a second, this can be simplified or expanded a bit more because I have a power here. So this power can be written in front. So this is 2 times the log base b of x. Okay, so I don't want any powers. When I expand it, I want it to be a multiple. This is a multiple, 2 times. I went from this being 1 time to being a multiple. And I'm going to rewrite the square root of y in its exponential form, which is y to the 1/2 power. So by your exponential rules, the square root of y is equal to y to the 1/2. You may recall that from another class. Okay, which gives me a power, which I can then put in front. And so this becomes 2 times the log base b of x. And then this power can come in front, plus 1/2 times the log base b of y. And that is fully expanded. Okay, it's a sum. And it's also multiple of logarithms. Here's half a logarithm, here's twice a logarithm. I can't have any powers, and I can't have any products or quotients as my arguments. So that's fully expanded. It has been written as a sum, difference, and or multiple of logarithms right here. Let's do another example. Always helps to see a couple of examples. Use the same properties to expand this expression, log base 6, oh my goodness, the cube root of x divided by 36 times y to the 4th as much as possible. Okay, so let's first off start by writing this out, log base 6. I have the cube root of x over 36 times y to the fourth. Well, it's a quotient. And we know that the log of a quotient is the difference of the log of the numerator minus the log of the denominator. So log base 6 of the numerator, cube root of x, minus log base 6 of the denominator, which is 36y to the fourth. Okay, well, just like up here, where the square root of y can be rewritten as y to the half, the cube root of x can be rewritten as x to the 1/3. So I'm simply going to write this one using an exponent, log base 6 of x to the 1/3. Okay, so cube root of x can be rewritten in exponential form as x to the 1/3. And this is a product. 36 times y to the fourth. The log of a product is equal to the sum of the logs of the factors. So this is log base 6 of 36 minus plus log base 6 of y to the fourth. Am I done? Nope. First off, these have exponents and they can be moved to the front to become multiple logs. And this actually has an integer answer. 6 squared is 36, so this is 2. So I can rewrite this as 1/3 times the log base 6 of x minus 2. Log base 6 of 36 is 2 because 6 to the second power is 36. And then plus 4 times the log base 6 of y. Now that is fully expanded. Sum, difference, multiples, and simplified of logarithms. Okay? We did expand. So now let's do condense. And as you might imagine, condense simply goes the other way. We're going to take a bunch of logs, get my paper straight. We're going to take a string of logs and we're going to write them as one log. So to condense, write the sum or difference of 2 or more logarithmic expressions as a single. So condensing, bring it down to 1. Well, here we have it. Use our properties or our rules to write the log, the common log, this is the 10 down here, of course, of 25 plus the common log of 4 as a single logarithm. Or if you can simplify it further, do that. So let's first write out what we have. And if you want to put a 10 in here, just so you can see it, help yourself. It's the common log of 25, which means the log base 10 of 25, plus the common log of 4. Again, it means the log base 10 of 4. Well, this is log plus a log. Well, that's the product. All right, so this is the log, the common log, base 10 of 25 times 4. And I'll just put an X in there, we'll be okay with that. Okay, we can do some math. This is the common log, and again, I'm going to put a little 10 in here just to remind myself 25 times 4 is 100. So now I have taken these two logs and I have condensed them to a single log. However, I can simplify this further. The log base 10 of 100, what exponent goes to a 10 to give me 100? Well, that's 2. 10 squared gives me 100. And you can check that with your calculator and you'll get 2 there, okay? So again, if you don't see the base and it says log, if you want to put a 10 in there to help you, help yourself. But it's the common log, it means it's base 10. Let's do one with that natural log, that base E, okay? Use logarithmic properties or rules to write this, which is 2 natural log of x minus the natural log of x plus 1 as a single logarithm. So let's start off. 2, I'm just going to copy it, 2 times the natural log of x minus the natural log of x plus 1. Okay, well, it is a subtraction problem, but I have 2 of these, so I can't use the quotient property yet. I have to take the 2 and move it back using the power property. So this is the same as the natural log of x squared minus the natural log of x plus 1. Now I have a natural log minus a natural log, and I can use the quotient property, which means this is the natural log of x squared divided by x minus 1, and that's as simple as it gets. There's no more simplification that can go on with this. It is a single logarithm. As a reminder, the ln is the log with a base of e, so we know there's an e base in all of these. That's using your properties to expand and condense logarithmic expressions.